All right, we're going to continue with graphing absolute value functions. And if you want to see the first couple examples, go back to the previous video. We're going to start with example 3 here. It says graphing f of x equals absolute value of x minus h plus k, and g of x equals f times ax. All right, so graph f of x equals absolute value of x plus 2 minus 3, and g of x equals absolute value of 2x plus 2 minus 3. Compare the graph of g and the graph of f. All right, so if you watched the previous video, you know that it's easiest to just generate a table of values and work from that table of values. So let's start with f of x. So we're going to have f of x. You get to pick your x's and then find your y's, or your f of x. All right, so let's start by looking at the vertex. We know that the vertex, by definition, is hk, so it's going to be opposite h, so negative 2 minus 3. So why is that important? If I come over to negative 2 minus 3, I know that's where my vertex is going to be. And when I make a table of values, I need to have points on both sides, left and right of my vertex, in order to get that V-shaped graph. So let's choose negative 4, negative 3, negative 2, negative 1, 0. We'll see if that's good enough. All right, so take negative 4, plug it in. Negative 4 plus 2 is negative 2. Absolute value of that is 2. 2 minus 3 is negative 1. Take negative 3 and plug it in. Right now we're looking at just f of x. So negative 3 minus 2 is negative 1. That becomes 1. 1 minus 3 is negative 2. Take negative 2 plus 2 is 0. 0 minus 3 is negative 3. Take negative 1. Negative 1 plus 2 is 1. 1 minus 3 is negative 2. And 0 would be 2. 2 minus 3. 2 minus 3 is negative 1. And you can see that these values do go negative 1, negative 2, negative 3, negative 2, negative 1. So hopefully using these values, we will get that V-shaped graph. All right, so especially since the vertex is in between these values that we picked. So if we go over to negative 4, 1, 2, 3, 4, negative 1, negative 3, negative 2, negative 2, negative 3. Again, that was our vertex. We already have that point there. Negative 1, negative 2, 0, negative 1. All right, let's see if I can use my arrows here. All right, that looks pretty good. That's a V-shaped graph that represents f of x. All right, now we need to make another table of values to represent g of x. All right, because g of x has a 2 here multiplied on the x, that changes this. This is not really vertex form. You can see the study tip. The function g is not in vertex form because the x value does not have a coefficient of 1. So the coefficient here is 2. So the vertex is going to be changed just a little bit. We know it's still going to be in this general idea, but let's use a table of values to see what g of x looks like. So we're going to go x and g of x, and let's choose negative 6, negative 4, negative 2, 0, 2. Just to get some different points here. So we're going to take negative 6. Negative 6 times 2 is negative 12. Negative 12 plus 2 is 10. absolute value of 10 is 10. 10 minus 3 is 7. Take negative 4, plug it in. I get negative 8. Negative 8 plus 2 is negative 6. 6, absolute value of that is 6. 6 minus 3 is 3. Take negative 2, let's plug that in. Negative 2 times 2 is 4, or negative 4. Negative 4 plus 2 is 2. Absolute value of that is 2. 2 minus 3. 2 minus 3 is negative 1. Take 0, plug that in. 0 times anything is 0. 0 plus 2 is 2. Absolute value of 2. So 2 minus 3 is negative 1. And then take 2. 2 times 2 is 4. 4 plus 2 is 6. Absolute value of 6 is 6. 6 minus 3 is 3. All right, so since this starts to repeat, we should get our V-shaped graph. All right, how about we change the color here to help us remember this is a different graph. Okay, so negative 6, 7. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All right, I think that's right. Let me count it one more time. 2, 4, 6. 2, 4, 6, 7. Okay, so that's my negative 6, 7. Negative 4, 3. And then negative 2. Negative 2, negative 1. And then 0. Negative 1. And then 2, 3. All right, so we've got several points here. You can see that I do not have the vertex here because I've got a point at negative 2, negative 1, and 0, negative 1. So I'm going to assume that the vertex is in between that and would be at negative 1. So we need to add one more point here. Okay, let's just add it here at the end. If I add one more point, negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. Absolute value of that is 0. 0 minus 3 is negative 3. So we should also have a point at negative 1, 1, 2, 3. All right. And this is the graph that represents g of x. All right, so as you can see, I generated this table and I didn't know from the beginning. You don't have to know immediately where the vertex is. Since there's a multiplier here, it changes things up. It's not just HK. So to generate this table of values gives me that shape. But when I found that there were 2 points here, but I wasn't down to the turning point yet. These 2 points indicated that there had to be a point in between here to be that turning point, the vertex. So that's why I chose the negative 1 to find the negative 3, and I can assume that that is the vertex. Now, it says to compare the graphs. All right, so if we compare these two graphs, we can see that they do have the same y-intercept. 0, negative 1. They both cross at 0, negative 1. You also can conclude that g of x is considered a horizontal shrink because it has a multiplier of that 2 right there. And you can see that they both still have that V-shaped graph for the absolute value. If you want to check these, you can use your TI-84 to graph these to check them to see if you feel like you did everything correct, especially when the vertex is not automatically on there like it was for g of x. So let's say if you want to find absolute value on your calculator, go to math, go over to number, ABS, it's number 1 right here, hit enter, and then I'm going to have x plus 2. I'm going to come outside the absolute value and do minus 3. Okay, so this is going to represent the first function. And then the second function, I'm going to go back to math, over to number, absolute value. This time it's 2x plus 2, and then minus 3. So you do need to be able to graph these using a table of values without your calculator, but it is nice to be able to check yourself once you get done. Okay, so if you want to look at those, you can see that my table here let's come down here and change this back to -10. And you can see those graph there. You also can go to your table of values. So if you go second table, and you can check your points here to make sure the table that you generated, you found the correct values when you plugged them in. So those are your graphs, and that's how you would compare the two functions.